Okay guys, so the first thing I want to talk about in section 5.3 is this first word problem. It's actually in the exercises. You guys are going to do number 3, which is pretty similar to number 1, but I wanted to talk through number 1 so that you kind of had an idea of how to write that. So number 1 is saying we've got this toy store that makes toy airplanes, boats, and cars. And so the first thing I'm going to do is come up with my variables for those. So they're talking about the materials that are used to make those things. So I'm also going to have that to think about. But the first thing I'm going to think about is these variables. So first I'm going to say that A for me represents airplanes, B represents boats, and C represents cars. I think it is, yeah. So then the second thing I need to think about is what materials am I talking about? So each airplane uses a certain amount of plastic, a certain amount of wood strips, and a certain amount of steel. The boats, again, use a certain amount of plastic, a certain amount of wood strips, a certain amount of steel. Same thing with the cars, right? So I need to think about equations for each of these. So like we've got plastic, we've got wood strips, and we've got steel. So I'm going to think about 3 different equations. I'm going to think about a plastic, I'll just call it wood or wood strips, and then steel. Those are going to be my 3 equations that I'm going to come up with. So a certain amount of plastic was used in each of these types of vehicles, right? So the plastic in the airplanes was 100 grams. So I would say 100 per airplane is how much plastic, 100 per airplane is how much plastic was used. Plus, I have in my boats, I had 50 grams of plastic. So 50 per boat. And then I had in my cars, I had 50 grams of plastic. So again, 50 per car, right? And the reason why I wrote it in this way, because a lot of people are really tempted to just say, like, I've got 100p plus 10w plus 200s. The problem is that tells me how to make an airplane, but I have no final information about the airplane, maybe how much it weighs or something. Instead, I have final amounts for plastic and wood and steel. So that's why I made my 3 equations, plastic, wood, and steel, because I have a total here for that. So my total for plastic was 10,500 grams. So that equals 10,500. Then I would go back and do the same thing for wood and steel. So for wood, I had 100, no, I'm going back here, sorry. I had 10 inches of wood strips in the airplane, so 10A. I had 100 inches of wood strips in the boat, so 100B. And then in the car, I had 50, no. In the car, I didn't have any wood strips, 0, because I had 50 grams of plastic and 150 grams of steel, so no wood strips in the car. So I had 10 in the airplane, 10 inches. I had 100 inches in the boat, and I had none in the car. Okay. Then my total for wood strips was 1,500 inches. Okay. Then my last one here is the steel. So total I have 25,500. I'm going to go ahead and write that in. 25,500 was my total. And then I need to go back in and find each one of the airplane, the boat, the cars. Okay. So my airplane for steel was 200 grams. So 200A. I had 50 for the boats, so 50B, and I had 150 for the cars, so 150C. So let me see if I can remember all of that. So it was 200 for the airplane, it was 50 for the boat, and it was 150 for the car. So this is how I would write my equations in that case, and number 3 is very similar to that, so kind of set number 3 up like that. Example 2 is probably my least favorite of everything in this chapter, but I have to teach it to you. So it's one of these things where they want to make sure you understand what reduced form of a matrix is. So in your book, let me see if I can find the page here. Sorry, there's a lot of pages in this lesson, so I'm trying to narrow it down for you. So on page 232, right here they talk about reduced form. So they give you this A, B, and C, but I feel like those are really confusing. So I just want to talk it through in examples. So I've got these 4 examples to talk about, and I'll tell you which ones are reduced, which ones are not reduced, and why they're not reduced. Okay, so this first one, there's something called leading ones. You need leading ones in each of your rows. So these are rows going this direction. So that first one right there, this one, the first one is right here. Before that is a 0. So this is a leading 1. And then this one, there's zeros all in front of it. So this is a leading 1. Okay, so each row has a leading 1. Above that, so everything else in that column, so if I'm looking at columns here, in this column, if this is my leading 1, everything else above and below that has to be a 0. So if this is my leading 1, everything above and below that has to be a 0. So this column fits that. In this column, there's my leading 1, everything above it is 0. This one is where the issue comes in. So here's a 1, that's my leading 1 in that row, that's my leading 1, and above that is a 2. That should be a 0. So everything in this column has to be a 0. So this is not in reduced form, so I'll just say not reduced. And the reasoning is because that column that has the leading 1 has a 2 in that column with it, and it would have to be a 0. Okay, in this one, one of the rules is that our leading 1s have to be what they call successive. So if this leading 1 is in column 1, and this leading 1 is in column 3, then the final leading 1 in this bottom row would have to be in column 4, because they have to go from left to right. So it's okay to skip this column right here. So it's okay to have that there. But this next one would have to be here then with zeros all in front of it. And that's not the case. There's a 1 here. If these 2 rows were switched, so let's say this was 1, 0, 0, 0. This next one was 0, 1, 0, 0, and then the final one was 0, 0, 1, 3. That would be okay because my leading 1s would be successive. So I just feel like as you're going from left to right, you should be looking for your 1s to kind of go downhill. Okay, so this one is not okay because really these 2 are kind of switched. So I'm going to say this is not reduced. And my reasoning is because my leading 1s are out of order there. All right, this one, I have a leading 1 here, leading 1 here, leading 1 here. This one is reduced. So that's kind of what I was talking about. They have to go from left to right. They have to go downhill. Everything in this column besides that leading 1 is a 0. Everything in this column, 0, except for the leading 1. Same thing here, zeros, except for the leading 1. So this one is reduced. So I'm just going to say reduced here. They may just ask you to say yes or no. Is it reduced or is it not? Okay, this one, I have a leading 1 here. Everything else in that row is a 0, or column is a 0. The next leading 1 down is over 1, but that's okay as long as down here I don't have a 1 in front of that one, which I don't, so this is okay. Everything in this column is a 0 around it. Same thing with this one. I still went down and over for that leading 1, and everything in that column is still a 0. So this one is reduced, even though that weird 2 is there. That is okay. It's still reduced. Okay. They want me to find an augmented matrix for these 2 situations. So they basically want me to take this information and put it into a matrix form. So that's really not too hard if all of your variables are in order. So they just have to line up. So in this one, I have a 3 in my first position, a 2 in the next one, and a -1 in the next one, and it equals 8. So there's that first part. The second one, again, I've got 1, 2, 3 in order. So this one has a leading coefficient of 1. This one has a coefficient of 1. This has a coefficient of 1. And then a 2 on the end. And then the last one, again, they're in order. So I'm happy with that. That would be a 2. That would be a 1. That would be a -1 because there's a minus there. And then a 5. So that one was pretty easy. This one, on the other hand, is not the prettiest. First of all, they're not in order, so I really need to switch things around here. But also, like this last one is really odd because this should be on this side. If it doesn't have a variable with it, it should be over on the other side. Same thing with this. I'm missing things in each of these. So I have a 1 and a 2 and a 3 all together, but these each only have 2 of those. So I need to be careful and fill in with zeros where I need to. So I'm just going to rewrite these. This would actually be negative x1 up front, so keep that negative sign with it. And then I have a 2x2. I have no x3s, but it equals 5. This one, I have a negative x1 again. I have no x2s this time. I have a 3x3, and I have a 2. And then this one, I have a 2x sub 1, no x sub 2s, a minus x sub 3. And if I add 6 to both sides, this is now a plus 6 over here, or positive 6. So when I write my matrix for this one, it's going to be -1, 2, 0, 5 on that top row. -1, 0, 3, 2 on the second one, and then 2, 0, -1, 6 for that bottom one. Just a side note for each of these are definitely not reduced matrices like these were up here, because we've got all kinds of numbers happening in there. Okay, the last thing that they're going to ask you to do is to solve some matrices or solve systems, right? You do not have to put it in matrix form, although I think the book might show you how to do that, and we will do that eventually. I'm just going to focus on solving the system, okay? So I'm going to start out in this first one by seeing what can I get alike. What I really would love to do in this one is take these bottom two and try to eliminate that z. Because if I do, if one of those doesn't have a z with it, I could put it with that top equation and solve for x and y. Then it would just be a system of 2 equations, which is a little bit easier. So that's what I'm going to do. The first thing I'm going to do is take this top equation, and I'm going to multiply it by -2 because that'll make this a -4. And then I've got a -4 plus a 4. That will cancel. Okay, so let's rewrite that. That gives me a -2x minus 4y minus 4z equals -6. Don't forget to take everything times that. This bottom one is just an x plus 6y plus 4z equals 3. So then I'm going to try to solve this out. So what happens here is this cancels like I wanted it to. And then this gives me a -x plus a 2y equals, that'd be a -3. So now I'm going to put this top equation with that. So let me line it up underneath here. And what you should notice is this one is really odd. So I end up with this canceling and this canceling and this canceling. So I get nothing on this side and nothing on this side, which is true. 0 does equal 0, but that tells me that there's something weird happening. And probably what's happening here is that z, going back to that z idea, there's something weird happening with z. So let's go back. Let me try to solve for a different variable here. So let me go back to, let's see, I think I'll use this equation and this equation, but this time I'm going to eliminate my x's instead. It doesn't really matter. You could try to eliminate your y's instead, but I think x's will be easier. So I'm not going to multiply by -2 this time. I'm just going to leave them as is. So I have an x, a 2y, a 2z equals 3. In that bottom one, what I'm going to do, I'll just write it down normal first. I think I'll change the signs in my top row. So I need to make one of those negative, doesn't matter which one. I'm choosing the top because that makes the smaller value out of these two negative, which means when I subtract, I'll get a positive number, which is what I wanted to do. Okay, so that's going to cancel. This gives me a 4y. This gives me a 2z equals 0. So I can simplify that a little bit. I can, let's solve for y. And here's why I want to do that, because then I can at least go back to this situation up here and plug it in for y and solve for x. And I'll show you why that helps me. All right, so 4y equals negative 2z if I minus 2z. And then divide, that gives me negative 1/2 z. Then let's go back up to this equation. So x minus 2y equals 3. So if I take this and I plug it in for y, that gives me negative 1/2 z right there equals 3. So that gives me plus, these will cancel. It's really just plus z equals 3. So that tells me that x equals 3 minus z if I solve for x. And if I solve for y, this happens. If I were to try to solve for z over here, it wouldn't work. So like I could try to eliminate my x's, I could try to eliminate my y's. I'm never going to get z by itself, because here's what happens when z goes away. It just keeps canceling and it ends up in this like not an undefined situation. What word am I thinking of? Infinitely many, sorry, an infinitely many situation. So they call that z being arbitrary. And you'll get one problem like that on your homework. The other two, because z is arbitrary, that basically means I can't give a value to z. So that means I can't really simplify this any further for y. And I can't simplify this any further for x. All I can do is write those in terms of z, that arbitrary value. Okay, so then let's do one where we can actually solve, because that one was a really weird one. You're going to see one like that. The one on your homework that is like that, let me look back, number 21. So when you look at number 21, again, z is the one that is arbitrary. So I want you to pay attention to that when you get there. Okay, let's look at this one though. This one we can actually solve. So the first one that I'm going to try to eliminate, I am drawn to this idea that those are the same. They pop out to me like right away. So I'm going to write down those two equations, 2x plus y plus 3z equals 1. My other one was a 2x minus 4y plus 2z equals negative 2. And I'm going to go through and change all of the signs I'll do my bottom row. So I'll make that a minus, that a plus, that a minus, that a plus. Put these together. So that's going to cancel out my x's. That gives me 5y. This would be plus 1z equals 3. So I could solve for z here. I'm just kind of thinking, what can I get alike here? So let me look over here and see what else could I get together. Let's solve for, let's do this. Let's eliminate my z's over here. I'm thinking about these two right here. So I'm going to do this, 3x minus 2y plus 4z equals negative 1. And this one, I'm going to multiply that by a negative 2. So I'm taking all of this times negative 2. So that gives me negative 4x plus 8y minus 4z equals 4. So that's going to cancel out my z's this time. So what I'm hoping to do is get both of these in terms of y, because I left my y's and my z's here. I left my x's and my y's here. So what do those have in common? They have y in common. So if I could solve for y here, that's going to help me, and I'll show you how. So this would give me negative x plus 6y equals 3. So now I'm going to solve for z in this one, and I'm going to solve for x in this one. So z here equals 3 minus 5y, and x in this one, negative x, equals 3 minus 6y, but that means x equals negative 3 plus 6y. So now I have this in terms of y and this in terms of y. And let me show you why that's helpful. If you can get both things in terms of y, go back to any of your equations, doesn't matter which one. I'm going to pick this very top one, and I'm going to plug these values in for z and x. So that makes this 2, let me write it first with just the variables. So 2x plus y plus 3z equals 1. That's my equation. This is now going to be 2 times x is negative 3 plus 6y plus y plus 3 times z, which was 3 minus 5y, equals 1. So now I have one equation with nothing but y's in it. So that's helpful because I can solve for y. So this is negative 6 plus 12y plus y plus 9 minus 15y equals 1. So I just distributed those. Then let's get some things together. 12 plus 1 is 13. 13 minus 15 is a negative 2y. And then these can go together. A negative 6 plus a 9 is a 3. So that means negative 2y equals minus your 3. That'd be negative 2. So y equals 1. So if y equals 1, I can now go back and say, let's plug it in here. So that means z equals 3 minus 5 times 1. So that means z is 3 minus 5, or z is negative 2. And x is, negative 3 plus 6 times 1. So that's negative 3 plus 6. So that's 3. So my answer, you could write them separately like that, or you could write it out as a ordered triple. Instead of an ordered pair, it's an ordered triple because there's 3 of them, and they would go in the order x, y, z. So 3, 1, negative 2 is kind of your final answer there. So a lot of solving systems of 3 variables is just figuring out how can I get to one single variable. So in my case, I said, let me get this in terms of y and get this one in terms of y, and then plug those in, and then I have nothing but y's, and then I can solve. Then going back and doing the rest are super easy. So see what you can do with that.